Hi, Tim Roberts, Application Engineer with Go Engineer. This quick tip video, I'm going to be discussing the setup for the porous media model in flow simulation. So we can simulate the resistance of batting, screen material, whatever that might be in our flow path that provides resistance. The first thing to discuss is the mathematical model this is based on will be found in your flow simulation engineering database. This is where all our materials are, as well as porous media definition. So we have its own category here. You'll find three simple predefines. By the way, you can have isotropic, you can have orthotropic porous media, and you're going to give it the material properties of that based on some mathematical constants. Okay, so you would come to the table with that, and very likely you will be creating your own user-defined. So feel free to use these predefined as go-bys. Okay, but that's going to be required. The second thing to talk about is the fact that we model a solid that represents the volume of the porous media model. For example, this blue part here in our catalytic converter. If we look at that, it really is just a solid body that fills the volume of the flow path. Okay, so we happen to have two of those here. But when you insert your porous media model, let's look at our flow project. That's going to be flow simulation insert porous media. When we do that, we end up with something like this, where the components are selected, our two blue parts, the monoliths, and we apply the mathematic porous media definition to it. Now, what happens in this process is that automatically is going to disable that solid component if you do a check geometry on it, which I would recommend on everything before you run in flow. You can see that the monolith models here have been disabled. Okay, so their geometry is not going to be considered. It's not going to be meshed, rather. It's going to use the volume of those components to apply the mathematical definition of the porous media model to give you some pressure resistance simulating porous media. So that's what's going on. That's just a real quick overview of the porous media model in flow simulation. Hopefully you enjoyed this video. Thanks for watching.